Good morning. We're going to take a look today at this piece of equipment right here. This is a Metalpro 4500 FS Ironworker. I generally just refer to it as a shear in the shop because, probably 99 cuts out of 100 that we make on this, we are simply shearing flat bar to size. This is the primary means of cutting practice plates for the welding booth when we make T-joints. Thicker material is not cut on this machine, it's cut on a bandsaw, which we'll cover in another video. But essentially, if it's narrower than 6 inches and it's quarter inch or under, it'll definitely be quicker, provided you don't need a real precise cut to cut it right here on this machine. We also cut 3/8 by 4 inch flat bar for fillet weld brake test, simulated mil-spec brake test on this machine. But that's the limit of 3/8 material that we cut on this machine. Again, primarily it is used to cut regular practice plates. Out behind this, I've got a couple of rollers set up. I'm here in the shop by myself today, so you may or may not see at some point in time in the video, intentionally or otherwise, there's some weld assemblies on the base of the rollers. That's just to keep them from tipping over without an assistant, and a 20-foot length of flat bar, that does tend to happen. So without further ado, we're going to give a walk around on this machine, go over some of the features, and then we'll talk about how to actually operate this machine safely. But essentially what we have here is we have a stationary machine. It's just a standalone piece of equipment. It's not bolted to the floor. On the business end here, where my hand is, we have a hydraulic ram. It's a double acting piston. And that hydraulic ram pushes a long arm across the top of the machine that pivots right here. So when that arm goes up on the right end, so over here, this end goes up, the other end over here will actually go down, and that will operate a punch die setup. Now that setup is not in operation currently at the school. I don't have the dies for it. It works in theory, but there's no dies in it. So we're not going to discuss that today. The primary thing we're going to look at is this module in the middle. Now this is a shear block. This can be removed by simply removing a couple of bolts and a cotter pin right here, and this can be replaced with a press brake or other various types of equipment that can be bolted into the center of this machine. So it's not only a shear. Metalpro Corporation, again, this is the MP 4500 FS, makes a bunch of accessories that go in the center of this machine. So this can do more than just cut things in half. Currently right now, I've got a piece of steel in here just as a gauge. I'll get to that a little bit later. But we have an adjustable plate right here that keeps the material from kicking up when the shear goes down. We have on this side right here, again, just from the opposite direction, the punch assembly, which we won't be covering today. And down below, and I've got the back lifted up so we can see through maybe a little bit better at different times. But down below we have the capacity to shear off angle bar and also to shear off round bar. Although personally I think doing that is it's a little bit more complicated really in terms of the bandsaw is probably almost easier to do it. Especially if you need a nice, accurate, clean cut. That does tend to twist the material just a little bit. Additionally, we have a mechanical stop. Now, this is not something that was on the machine when it was brand new. This was added here at the shop. But this simply allows us, with an adjustment, to move this arm around. Let me bring this up. And we can, set this as a mechanical means of limiting how much material comes out of the back of the shear. So if we need to cut something to length repeatedly, this gives us a quick way to do that. Right now, for this video, I have this gate lifted up. And this again is for visibility, so I can get a few shots of what's going on the cutting side of this, on the business end, so to speak. we wouldn't normally have that listed up during operation. That will lift up automatically when you shove the piece of material through, okay? Now the power switch is located right down here. Basically, you just reach in with your hand and turn that on. This bin on the back side, which was built by a couple of students a few years ago, actually is just sitting there, so you can easily slide this out to get access to the switch or to the machine or to anything else. It is designed simply to catch the material as it falls out of the bottom of the shear. In terms of safety of operation, the biggest thing with this shear to look out for are pinch points. This entire assembly goes up and down, so as this lifts, we have movement here, we have movement in this plate on the inside. Of course, this entire internal die pack, which I guess I'm going to come around. I know this is helter-skelter, folks. I apologize for it. That entire plate moves up and down, so you never want to get your fingers anywhere near that. But again, you could just as easily be leaning on the machine from the opposite side. Obviously not where it's sitting now, but the machine isn't necessarily always going to be right here. And again, there are possible pinch points in here, pinch points here where my hand is, again, underneath here. So you've got to be super, super careful and relatively, confident that before you press the foot control, again, this is simply ram up, ram down. That's all it is. That's the entire control mechanism for this machine. But you want to be sure that before you step on that lever, you know exactly where your hands are. All right, in terms of basic operation, the setup is pretty much like this. We're going to reach down in here. We're going to flip on the power switch once the machine's been plugged in. I'm going to shove the bin back in place just to increase the likelihood that I don't miss it, you know. Now, without a setting for a mechanical stop, and I apologize for the noise, what I basically have is I have an adjustment. This adjustment right here, this goes up and down. This is designed to prevent the plate, again, from kicking up. This is essentially, I'm stepping on the lever up. This will rise up, and when it does, a hole in that plate allows the piece of material I want to shear to go through. One of the most common issues with this is that people seem to think that the higher they raise it, the more clearance they're going to have. Well, in fact, the plate is going through a long slot. So if you lift this up too high, and I'll do this right now, keep an eye on this corner, and right there you just heard a little grunt. Let me go back down. Listen. Okay. At that point, we're all the way up. What that means is, that slot is too high to allow our piece of material to slide through. So, in general, in order to access the material for shearing, that corner on this piece of plate right here, which is the actual shear plate, only needs to be above this orange surface by approximately the thickness of the plate you're shearing. So you don't need to raise this way up in the air, okay? There's no need for that to go up in the air. The other marks that are on there, there's a pencil mark or a marker mark, if I can get out of the light here. That line at the bottom is the maximum height you'd ever have to lift this, period. That's when it bottoms out. And that mark right there is the maximum height you'd ever have to lift it to get the other things that it's designed to cut through the hole, okay? So again, this only needs to come up by about the thickness of the material, and as you can see right now, it's up higher than it actually needs to be, okay? That having been said, we'll take the piece of material we're going to shear. This is A36 flat bar, 2-inch wide, 1/4 inch thick. I'm simply going to slide it through, okay? I have no particular mark I'm going to cut. The adjustment has been set so that this plate has minimal movement, and I would say, you're going to want a 1/16 or less. The thicker the material, you can have a little bit more movement, but ultimately this should slide through without binding on this plate. And again, there's a spring under here, so I can push this down, but this limits the upper travel. So I want it to slide under with enough room to move freely, but I don't want any higher than necessary. So I'm going to slide the plate through. I'm going to come around the other side so we can see what's happening. So right now we can see that the plate is sticking through the slot, and I'm going to operate the shear. Now the foot control is again pretty simple. Here it is on the floor. I know this is a crazy video in terms of, I can't imagine what it looks like watching. But I'm going to put my foot up above the ram down, and we're going to come up here and we're going to film this. We're going to watch what happens. So right there, it just sheared off this piece of steel. And again, just like butter, okay? So if it'll go through this, it'll go through you. So on the opposite side of the shear, what we have is we have an adjustment gate. I'm going to just drop this out of the way for a minute because it's easier to deal with this short piece of bar. This is the same thickness of material that I had before. Basically, this gate adjusts up and down, and I'm going to start off by turning these knobs down to where this won't physically fit under, okay? This gate is designed to prevent the back end of the plate from kicking up. So for demonstration purposes only, and I'm not going to cut all the way through this part, I'm going to raise this way up. So this is excessively high. I've got a tremendous amount of clearance here. I'm going to turn the power on, I'm going to bring the shear in, and I'm going to just lightly touch down on that, and you watch the back end of this plate. So we're going to be noisy here for a second. Grab my safety glasses. Okay. What I'm going to do basically is I'm going to slide this in where I know it is going to shear. I can see through here by my eye that it's in the shear plane. And I'm simply going to lower the ram down lightly and let that bump. So right now, this is lifted up off this deck. It's bumped against this plate. If I were shearing a long piece of material, this right here, back 5 or 6 feet, maybe where your assistant is helping you feed the bar in, could rise up high enough to actually hit him in the face if he's leaned over it. So it is very, very imperative that this be held down. It also means that the quality of the cut is not going to be good. Instead of cutting the material off nice and square, it's going to shear through it at an angle. Again, I'm going to raise the ram back up, just to kind of gain some clearance. I'm going to turn the power off for a second. Essentially what I have here now is I have a large gap I'm going to fix. I want to bring this down evenly. I could in fact lower only one side. I'll do that right now. That's not in my best interest. So what I'm going to do to get this in the ballpark is I'm going to set one side to where it just clears, okay, way over here. And that way I know that this is going to be more level. I'm going to go to the opposite side. I'm going to do the same thing. And I'm going to adjust this till this is just rubbing. So now in theory this should be flat. I'll check this in the middle and make sure that this is going through. Right now, and I know you can't see this on camera, this is stopping not on the shear plate, but on the inside edge of this channel. This orange piece is actually a piece of channel iron. It's got another piece of material on top of it that's been welded on to prevent the slight bowing that was happening over the course of the last 3 years. So what I'm going to do now is I'm going to evenly raise this up. So if I give this a little quarter turn, I'll give this a quarter turn. And right there, the plate goes clean through. All right. If I have major problems with it binding during operation, I might raise it another quarter turn, but ultimately, I want this plate to be minimally I'm going to power this thing up, folks, and we're going to shear some flat bar. I'll show you how this operates kind of in real time. I will move the camera to the back side after I've sheared about half of it, so you get a view from both ends. But here we go, power's on. Again, I want the ram up high enough that this shoulder is approximately the thickness of the material above the plate. I can then push this through with, I'm going to hold this against the guide to try to keep it reasonably square. Although it's a practice plate, there's no real need to have the end perfectly square, but it is nicer, a little more professional. And again, you can't see this on camera, but I'm going to step on ram down. Put ram up. When I see this clear, I can shove it through. Ram down, up, through. Again, down. So as soon as I see that corner right here come up above, I just push the flat bar through and I take my foot off the ram up. I don't need to lift it any higher than that. So this is much faster than the bandsaw. For practice material, it's plenty accurate enough. And we could not keep up with the bandsaw. So this will shear material much faster than the class can consume it welding. I can't say that about the bandsaw. We can almost weld it as fast as we can cut it, even if we're cutting large bundles. All right, I'm going to move to the other side. So we'll try to get the camera around here. And we will readjust as best we can. Let's see what kind of a view we can get. All right, again. Backside, the gate is up for visibility. There we go, ram up. Kind of a little unique. I'm going to bring the camera around and show you this. The very last piece is not long enough for me to put all the way through and still grab the back side. If I pull this through, I cannot get a hold of the back side of my fingers. It is still supported, however, by the guide. So I'm simply going to hold this through manually from the rear. Again, we got a grasp on this very, very lightly. And then I'm going to give a tap on the down button, and I'm just going to bring this down until I feel it grab. So right there, it's got a hold of the piece. Now I can simply let go. I can shear that last piece off. The small part that's still trapped in there, I'm going to just push out with another piece of flat bar. And that's it. She's clear. All right, the next thing we're going to do is we're going to cut off a piece of angle bar. In the process of shearing angle bar, we will need to raise the ram up high enough that we can see clearly through this area right now. Right now the ram is all the way down. So because of the noise, I'm gonna lift this up. You're gonna be able to see through. I'll take the camera out and I'll move it. It'll be a little bit crazy, but I'll move it. And then I will get this positioned in place to cut. And I'm gonna move the camera around to the back side so you can actually see the cut happen. All right, now I've already made one cut with this on the angle bar before. So what we're gonna see in addition to the angle bar falling out is the slug that's cut out, because this actually cuts the angle bar in two places in order to support it. And that'll make more sense in just a minute. So power's coming on. All right, we're gonna lift the ram up. And again, I need to be able to see all the way through there. This does not necessarily need to go up until it grunts on us. We'll pull the camera out real quick. And again, we want to be able to see clear through. If I lower the ram down, you can see how that gate kind of closes off, okay? Like a little chevron. Want to make sure that that's all the way clear through. I'm going to set the camera back down. And again, I'm going to slide the angle bar through. Now, I'm not using a mechanical stock for this demo, just because I have no need to cut this angle. I'm just cutting it solely for the purpose of demonstrating the process. The angle, of course, is too long, so I got to tip the camera back. And she's now through. Okay. So right now the angle is just kind of hanging there. In the process of cutting this, I would hold this upright. As I bring the ram down, as the ram contacts the angle bar, it contacts in between two supports. So it will kind of self-level, but again, you want to hold it level to begin with. And I'm going to bring the camera to the back side so you get a better view of the shear. But again, you need to hold that up. Again, over here, we'll get a nice view of the cut. And I'm going to pick this up so it's roughly level. We'll assume for argument's sake that this is where we want to cut. I'll bring the ram down. Now once that's cut, I'll pull the angle out the back side so it's no longer being supported. Now, here's the cut we just made. Okay, so we have a nice clean cut with the angle bar. Additionally, we have the slug. This is 3/4 of an inch thick, okay, approximately. And this is the piece that gets peeled out between the two supports. So one of the reasons I don't like cutting angle bar on the shear is because we waste, 3/4 of an inch or so of material with every single cut. Now, it is fast, it is quick, and again, if I measure off the little angle piece and I set the support up like so, I can get very accurate cuts all day long, but it is not a good use of material. Lastly, folks, we can shear off round bar as well. Again, this is designed to be used on multiple things, so round bar is one of the other options. In this case, I have threaded rod, only because it's what I have on hand, just for demonstration. I'll cut off a short piece. Parts through, I'm going to bring the ram down. So again, when that part sheared off, I just stopped early. It just didn't happen to fall out. It does quite a bit of damage to the end of the piece. So cutting threaded rod would not be what you'd want. And again, if you're looking for a precise cut, the shear is definitely not the way to cut round material. All right, folks, at least in terms of what we do here at Bath Tech at this point in time, this is the fall of 2020, that is the capacity and capability of this machine. Eventually, I may have a punch. I'll do another video on the punch. I may have a shear, a brake to go in the middle of this so we can actually bend material. I think the brake for this machine is 12 inches wide, 12 inch capacity, so it would be a really great thing to have. Ironworkers are awesome machines. This is a very simple one in terms of what it's capable of, but they're also machines that are, easy to forget how dangerous that they are. Again, watch for pinch points. Make sure that you are cutting material that is within the capacity for the machine. I'll list the capacities at the end of the video. In terms of what we're doing in the shop, it's mostly 1/4 inch flat bar, 2 inch, 3 inch, and 4 inch for various purposes. We do cut 3/8 by 4 inch flat bar for BIW type mil spec fillet brake tests, but it really doesn't have a lot of regular use other than that. It's not that we couldn't use it for projects or other endeavors, but for the most part it was purchased as a way to cut material more quickly and efficiently than the Ellis bandsaw. So in terms of kind of closing up, again, make sure when you start this machine that you give it a general inspection. Make sure that you have your adjustment correct. Again, if you're cutting angle bar, you measure off the small angle here. If you're cutting anything else, you measure off the round bar. You want to make sure that this is lined up with the part that you're cutting so that it does in fact stop it nice and cleanly, not just barely catching the edge. The T-nut on the opposite side should be good and secure, although you don't need to put a pipe on it and over tighten it, it just needs to be secure. As long as you're not slamming the part that you're cutting into the support, it will stay adjusted and it'll produce nice accurate work. The vertical adjustment on the opposite side that we covered earlier needs to be set. If someone's been cutting 3/8 flat bar and then you come in here and you put in 1/4 inch bar, when that bar is way back here and you have an assistant helping to push that bar through, I've seen that bar come right up and knock someone's ball cap off their head. Very, very close call. Happened the first year that we had this because people did not take proper precautions in setting up this, what looks like a very simple piece of equipment. So use it with respect and it'll do good work for you.